So yesterday we investigated linear pairs and vertical angles. Today we're going to look at special angles that happen with parallel lines. Okay, so first of all, just a quick review. Remember, parallel lines are going to be coplanar, meaning in the same plane. They do not intersect. And remember, we do have our symbols here to show that lines are actually parallel. And just so you know, you can also have planes that that do not intersect, so planes that are parallel. Here's an example of that. We don't deal with that a whole lot as far as any kind of calculations or anything, but do be aware that planes can be parallel, just like when we were looking at three-dimensional objects. Remember how we talked about the bases of prisms? The bases were going to be congruent polygons and they were parallel to each other. Okay, so those are planes that are parallel to each other. Now, when we have parallel lines, such as here, where we have these parallel lines here, any line that crosses that is called a transversal. Okay, so it's a line that intersects two or more parallel lines. All right, so this is just called a transversal. A lot of times they label it with the letter T. Now, what happens is that transversal ends up creating, in our case, since we have two parallel lines, it ends up creating, 8 different angles here. So it ends up creating 8 different angles, and a lot of angle relationships happen in here. And that's what we're going to look at today. So the first set of angles that we're going to look at are called corresponding angles. Okay, and we talked about corresponding parts before. Remember when we were talking about congruent polygons? Talking about congruent polygons, and we said corresponding parts had to be congruent. Okay, well, we have corresponding angles that happen here too. So we said corresponding meant like in the same position. So for instance, if you look at 5 and 4, angles 5 and 4 here, they're considered to be corresponding because they are both sitting on top of a parallel line and to the left of a transversal. Okay, so we have, let me see if I can get some colors going here. So we have 5 and 4. Then we have 1 and 7. So 1 and 7 here. Those are called corresponding. We have 6 and 2. Those are corresponding. And finally we have 3 and 8. So the names of those are just corresponding angles. Okay, now there's special properties that go with that, and that is corresponding angles are going to be congruent. So corresponding angles are congruent. I don't know where my pen is gone. Let's try this again. Congruent. So in our case here, angle 4 is congruent to angle 5. Angle 1 is congruent to angle 7. Angle 6 is congruent to angle 2. And angle 3 is congruent to angle 8. Okay, so those are called corresponding angles, and they are congruent. Now, in every geometry textbook is a little bit different, especially with the way they do proofs. A lot of times, corresponding angles are considered a postulate. Okay, and for our purposes, we're going to consider this a postulate, meaning this is something that we can just assume to be true. Okay, we can just assume for it to be true. We don't have to prove it. Okay, and we're not going to prove any of these today. We're going to do that tomorrow. But keep in mind, this is going to be our postulate. And I'll review that a little bit tomorrow and show you why that's going to be important to us. So make sure you have here, you understand the idea of corresponding, and you write down that they are congruent. Okay, our next set of angle types are alternate interior angles. Okay, so let's start with the word interior here. Let's start with the word interior. So interior means inside, in between the parallel lines. So if you think about like the parallel lines as being like pieces of bread, so this parallel line here, if those are pieces of bread, okay, they're inside the sandwich. They're interior. Okay, now alternate means different sides of the transversal. Okay, different sides of the transversal. So let me clean this up a little bit here. All right, so in our case here, we have alternate interior angles 1 and 2, so 1 and 2 are alternate interior angles, and 3 and 4 are alternate interior angles. And what we're going to find is that alternate interior angles are also going to be congruent. Oh, goodness gracious. What's going on? Let's try this again. Congruent. Okay, alternate interior angles are also going to be congruent. So in our case here, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And those are called alternate interior. Really, if you look at the name, it kind of describes where everything is, which is handy when we do the next one. Our next ones are called alternate exterior angles. So think about what that means. Exterior this time is outside of the parallel lines. So again, look at my parallel lines, see where they are. Okay, so here's my parallel lines. Okay, notice the angles are now that we're focusing on are outside of those parallel lines, outside of that sandwich, if you want to think of it that way. Okay, again, we're talking alternate, meaning different sides of that transversal. So the pairs that we're looking at this time are going to be 5 and 8 and 6 and 7. Okay, alternate exterior angles are also going to be congruent. Okay, so fill in that blank. So for us, that means that angle 5 is congruent to angle 8, and angle 6 is congruent to angle 7. All right, so those angles there are going to be congruent. Okay, one more angle pair that we need to look at. And these are called consecutive interior angles. Some books call them same side interior angles. It really means this exact same thing. Those terms are interchangeable. So in this case, we're talking about interior angles again, so inside. But this time we're talking about the same side of the transversal. Okay, we're talking about the same side of the transversal. So we're talking about, for instance, angles 2 and 3. Or we're talking about angles 1 and 4. So clearly, just from looking at them visually, you can see they're not the same. They're not going to be the same measure because this angle up here is acute, whereas this one is obtuse. Okay, so visually you can see they're not going to be congruent. In fact, what they are is supplementary. They end up being adding up to 180 degrees. And again, tomorrow we're going to worry about proving that tomorrow. And the proofs go actually pretty quickly, but keep that in mind. So all of our angles that we've looked at are all congruent, except for these same side interior angles here are going to be supplementary. All right, so let's take a minute here. I'm going to give you a few seconds. I want you to solve for all the missing angles. Okay, if you haven't had enough time, go ahead and pause the video. But again, remember we have linear pairs and we have vertical angles. I always say go for those types of things first. So in our case here, we know that 110, the vertical angle to that is 2. So I also know that this has to be 110. Okay, and I can also find angles of 1 and 3 because really if you ignore the bottom of the problem, if we just focus on this vertex right here, this is what we did yesterday. Okay, so we know angles 1 then, or angle 1, because of the linear pair right here, because of that linear pair, this has to be 70 degrees, as does angle 3 because of vertical angles. Now we can use our skills from today, those special angle pairs. If I look at angles 3 and 4, those are alternate interior angles. So I know that 4 has to be 70 as well. And then I can go my vertical angles again. So angle 7 has to be 70. Which leaves then my linear pairs to determine that, angle 5 and angle 6 are 110. Now, the beauty of this, I know you're not thinking there's any beauty here, but the beauty of this is, I chose to do vertical angles, or I'm sorry, alternate interior angles here, but really I could have done corresponding angles here and here, right? Or corresponding angles here and here. Or I could have done alternate exterior angles here and here. So there's really not one perfect way to do it, and that's the nice thing, because there's so many ways to work around it. I mean, granted, this was a simpler problem, but a lot of times the pictures are going to get much more complex. Okay, so let's do one more problem here. This one doesn't involve just simple angles or simple angle measurements. We have some algebra involved. So it says if the measure of angle 1 is 3x plus 40. So we have 3x plus 40. I'm going to write that in there. The measure of angle 2 is 2 times the quantity of y minus 10. And then the measure of angle 3 is 2x plus 70. I'm going to solve for x and y. Okay, now, sometimes it's easier to look at things at bits and pieces. So sometimes what I do is notice our two lines that are parallel. Okay, these two, oops, I'm sorry, let me undo that. These two lines right here are the parallel lines. So this is a transversal for that parallel line. Okay, so what I'm going to do is mentally kind of just cover up part here. See if I can get this out of the way. I can't figure out how to rotate that, but that's okay. All right, so we're just going to focus on angles 1 and 3 right here. So think about what kind of angles are 1 and 3. So remember, we have corresponding, alternate interior, alternate exterior, same side interior, not vertical, not linear pairs. Okay, so I recognize that these are corresponding angles, which means corresponding angles have to be congruent. Okay, so I know angle 1, oops, kind of lost my tick mark, angle 1 and angle 3 have to be congruent. So that means I can set those equal to each other. So 3x plus 40 has to be equal to 2x plus 70. Okay, so if I subtract 2x from both sides, I have an x. Subtract 40 from both sides, I have 30. Okay, so I have my answer for x. Okay, now let's go back here. Let me get rid of our box. All right, so now we got to figure out how 2 is related to those. Now, go back and look at, we have another set of parallel lines actually. You see the double arrows? So we actually know that these two lines are parallel. Okay, but what you need to understand is that 1 and 2 share this transversal. So there's probably a relationship between 1 and 2 somehow. Notice on this transversal, there's just angle 3. Angle 2 does not lie on this transversal. So this time, I'm going to ignore, I don't know if I can do this again. I'm going to ignore this part over here. Okay, I'm going to ignore this part over here. So I'm just going to look at angles 1 and 2. Now think about 1 and 2. What is their relationship? We have the parallel lines. They're outside of the parallel lines. They're on alternate sides, so those are alternate exterior angles, and we know those are congruent. All right, so because they're congruent, I can set them equal to each other. So I have 3x plus 40 has to be equal to 2 times the quantity of y minus 10. Okay, I have the problem of x and y, but keep in mind, we just solved for x up here. So really we have 3 times 30 plus 40 equals, I'm going to go ahead and just, well, no, we'll leave this. 2 times the quantity of y minus 10. So 3 times 30 is 90. 90 plus 40 is 130. So really, I could have just said earlier, oh, well, this is a 130-degree angle, and then set 2y minus 10 equal to 130 degrees. Either way is fine. All right, so to solve for y, I'm going to then divide by 2. So I get 65 equals y minus 10. Okay, so then I'm going to add 10 to both sides, so I'd have 75 equals y. Okay. Okay, so tonight your homework is out of your book. I want to kind of give you a fair warning about number 7. Okay, number 7 is it's a little more intense. So I'm giving you an extra paper copy of number 7 just so you don't have to redraw it. Okay, so let's look at what that is. So this is what number 7. I'm sorry, it was number 7. This is what number 7 looks like. Okay, so you're finding the measures of angle A, B, C, D, and so on. If I were you on your homework, at least this is what I'm giving you a printout of. I would at least write like A equals, B equals, C equals, D equals, like write that all to the side. Because tomorrow when you check your answers, if you can just go down the list and check it versus having to search through all of this to find the A, the B, and so on, it'll go a little bit faster.